Okay, thank you. So as I said, this will be a very small session, and we have like created our model, and we would like to do the final things. That's basically deploying it. So as we made this model here, we actually like found the accuracy. We have the model here, which is with, yeah, the decision tree object. This is the object of the model. It has all the parameters that we need for like predicting and all. But then this is inside this environment. This is inside this Jupyter notebook. We want to actually deploy it somewhere else. Your deployment server could be somewhere else in a like a production environment, in a environment. So you want to like save this model. Once this Jupyter notebook is closed, these parameters will be gone forever. You won't know it. So what you want to do is we want to save it. So how do you save a model into a file? Why do you want to save it into a file? Because that's how you can like use this file in a different environment again. So how do you save it into a file? I just copied the code quickly so that we don't like waste time typing it again. So we have the joblib library in Python. We have a job library named joblib, and it provides us ways to like store our objects, like Python environment objects like lists and everything that we have, lists, dictionaries, or complex objects like the decision tree object that we have created. It allows us to serialize it. Serialize it basically will convert those objects into bytes and will store it into a file, which obviously we won't be able to like run it, open it, unless and until we'll use joblib to load it again. So I've imported dump as well as load. Load is not used here. Load is when we'll load the model in the another environment to like run evaluations on it. So which model we will load? Dump and load is basically the model that performed better. So we got 81% accuracy on validation set. Again, accuracy is not the only measure. There are things like F1 score, your sensitivity, and everything. You want to check once you have got a good accuracy or something. You want to check that how many positives, like how many examples that were true and your model predicted them as true, and how many models that were false and your models predicted them as false. Like stuff like these, how many inputs were actually false and your model predicted them true, or how many more was actually true but then your models predicted it as false. So in different topics and different problems, like in a medical problem it would be more important so that you don't make false positives. So basically you don't want a person who had cancer. It's more important that you don't predict if he has a cancer, because if you didn't predict, like if you created a false positive, sorry, if you created a true negative, I guess it's very confusing. Yeah. So if you created for time, if you did something like the person had cancer, but you said that he doesn't have cancer, it's it's worse than predicting if a person didn't have cancer and you predicted it has cancer. Because if a person didn't have cancer and you predicted him saying that this guy has cancer, and this person then goes to a doctor, the doctor would be able to make out that okay, this person didn't have cancer, and you made a mistake by predicting it. Usually the models are placed before doctors. I mean, the model would predict something, then the doctor would evaluate, like check it, because obviously the model can perform much faster than a doctor in most cases. In the second case, now what would happen is basically you have predicted that the person doesn't have a cancer, doesn't have cancer, but then the person actually had cancer. So this person would never go to a doctor now, and this is worse than the other case when the person went to a doctor and had changed, but now they just made a mistake that was not able to be corrected. So in that case it's more important to predict the wrong thing. And now you can see it in a different manner, saying that for the couple of days when the patient was thinking that he has cancer but he didn't have, so he was very emotionally very much disturbed, so it affected him. So if in a case that is more important, that you will try to change that. And changing your parameters not only changes your accuracy, again you change your true positives, your false negatives, you change your false positives, you change your false negatives, you change your true negatives, all those sorts of things change. So depending on the problem, you need to go see what the environment, what the literature has done. You will ask the stakeholders what's more important, and then you will create a model applicable to it. So in this case we are just doing the accuracy, and we are basically dumping the model. Dumping is a nice way to like serialize serialize your model, and you just give it a name of the file that you want to create, and you dump it. Once you have dumped it, it will get stored in the file system of this environment as a serialized binary object that you can't open obviously, but then another Python function would be able to deserialize it by calling the load function. So again, Kaggle is a integrated environment on the server. What it stores on its when I run this, it actually stores it. So but we won't be able to access it because it's on a server. So what we would have to do is we have to get it on our machine. So for Kaggle to get something onto our machine, to download something, once you have written it to the file system, you have to save the version. You have to save and run all commit. Once you do this, it will run this entire notebook from top to bottom in a different machine, I mean in a different container, and then once it's done, we'll wait for it to, and it will be done quickly. Okay, so once it has downloaded it, now once it has created that stuff on the CPU and you created the version, it's created that in its own file system. So we have created this checkpoint here. What we'll do is we'll open it in a viewer inside of Kaggle again. These are Kaggle specific things. If you're training it on your own notebook, on your own machine, when you run that dump command, it actually gets saved in your file system. So you don't have to do these things. So when you go to the output, you can see this decision tree.joblib. This was the file name that we gave to this thing. This is the file name we gave it here, and you can actually see it has come here. Now you could just download it, and when you download it, open it. So you have this decision tree.joblib here. So what has happened now is your model has actually been downloaded into your system over here. What I need to do is basically create a script that could use this model and run it. So it's stored in the downloads folder. I'll have to copy it into the environment I want. So basically, again, so how do I run these things on my own machine? So I'm using a Anaconda distribution. You can see online how to install Anaconda. Usually I use virtual environment with basic Python, but then I thought this would be simpler to show. Again, there are trade-offs, so you can use whatever you want. Anaconda is basically a data science specific version of, not version of Python. So it basically, Anaconda gives you it makes it easier for you to create environments with the libraries that you need, so you don't have to go online, search for a specific library and download it. It's again making easier for you to do your analysis. So this is the Anaconda prompt that I've opened, and I've copied the model here. Ubuntu, yeah, habit of Ubuntu. Okay, so here, as you can see, this is the dictionary.joblet that I copied on my in my downloads folder. So where did I copy it? I copied it here. Local disk users in my own folder. Why I did this here is because what I wanted to show is, in a corporate environment, usually you don't have in many places, not in the consultancies and all, they won't provide you access to your machine fully. So the machine that you'll be using, you won't have access to the entire C folder. You'll usually have it inside. You will only have access to the folder of your name in the users. So basically you can create a project folder here, and you can do only things over here. You won't be able to edit stuff over here. Only you would be able to do stuff in this folder. All the other folders won't be accessible to you. So what I did was I copied it over here, the decision.joblib file that I had downloaded. Now it's ready for me to like load it. So I wrote a script yesterday. I'm not writing it now because it will take a lot more time. So yeah, so I already, okay. Shit. Okay, so this is the small script, a very simple script of showing how do I use my model for prediction. What I'm doing here is I am loading using the using the load command, a load function to load this decision tree.joblib. If your model is inside some folder, you can write the folder name here and then like put the slash and then put the name. Like it's just giving the path of the joblib thing there. Okay. And then I'm running a while true loop. So while to loop basically will make this part run again and again and again and again. It won't stop until unless you don't press Control C or something to stop it. It's an infinite loop that I've created, and I'm taking the all the parameters as input: fair, embark, PC class, FSP, parch. I'll run the file that will make it easier to understand what's happening. So when I take the input and I'm actually converting them to the respective data types that I need. So in the initial folder, age, fair, and P class, FSP, and parch, they were all floats. They were all already numerical values. And sex and embarked were characters, like they were strings. So basically in Python, the default type is string. So when you are not accepting a string, you need to convert it to a float. And in this way, I made it very simple. You have to do validations and stuff, but then I'm just ignoring it for now. Ignoring it, and I'm just not avoiding it doing now because it will take more time. And that's something that you can do later. And then again, if you can see, this was the exact same dictionary. Usually when you do your cleaning and all here, you will end up creating these dictionaries. And then when you, where did it go? Okay, where was it? uh, yeah, so I created this dictionary over here, and then I mapped it to a data frame. So what you want to do is you will copy these dictionaries exactly into your this code. So and then you'll use this dictionary later on to do like cleaning on the data that the user has inputted. The user wouldn't make sure that it will input a 0 instead of a male. It's difficult for him to do that. Or maybe you are using the same database now, accessing it and getting the data, so you have to do the cleaning on the test data also. So basically I'm using the same dictionaries. I copied it from there. I actually copied it. It's better to like make sure that those are exactly same. And the sex that I inputted here was a string. It could be male or female. And as this is a Python dictionary, I can directly like x equals to sex dictionary 6. So what happens is basically when you put male or female here, it takes the respective values and it assigns it to sex. It's the same with embarked also. When you put embarked here and use the embarked dictionary, you put it into embarked. This is how I had cleaned the, I had like converted strings into categorical variables there. The other variable feature engineering that we had done was I had generated the family size from parents and siblings plus one. Again, I copied the exact same file, exact same line from there to do this. Then I had this thing where I was assigning bins to ages, like converting again age to a categorical variable. And then I did the same thing here. And once I'm ready with it, I load the model here once. We have to make sure that we don't need to load the model each time a user has inputted something. You just do it once, and then for each input you just predict it. And again, when I have created these variables out of the input, I want to predict on it. So how do you actually predict? You pass in the variables to the predict function of decision tree. If you had seen, I had used something like predict. Yeah, on that in that case also, but I was passing the entire validation data frame. Here I am passing only a single example that the user has entered. What something One more thing that's really important here is to make sure that you use a list of a list. So the predict function expects you to give it a list of different different test examples. So it doesn't expect you to give a single example. So you have to make sure that you convert your list into a like a nested list. So if I have to add another example here, I'll just copy it here. So that's how it expects it. So you have to make sure you have to put these extra square brackets or something to show it that this is not the dimension, like this is the way you are giving the example. It's just a something implementation detail that you need to do. Okay, now I have the file ready, so I'll just run it. And when I do this here, I'll just run Python. What is the name of the file? Test.py. Okay, now it will execute this file top to down, and it's loading the model for the first time, so it's taking time now. So as you can see, if I would have put this here inside it, it would have loaded each time. And if it would load each time, you will like wait, you will have to wait for the user, like user will have to wait a lot. Yeah, so now it has loaded the model here, and it expects us to put in the parameters. So what we'll do is we'll just go in and we'll take a example from here itself. Okay. So we'll take this example. So in this example, we have the male, sex as male, so I'll put male here. The age of the user is 22. Put the age here. The fare is 7.2500, so I'll just put 7.2500. Embarked is S. P class is 3. And sibling SP is 1. Parch is 0. Okay, so it gave the output as 0, which means it gave the output as the person will not survive, and as you can see, the person has not survived. Now it is asking, it's waiting for another example that you can put. So now we'll try this example. Uh, Now you need to put the age, which is basically 38. The fare, which is 71.233. 71.28. Embarked is C. P class is 1. Sibling SP is 1. Parch is 0. It predicted that as the person has survived. So it was from the same distribution, the same example delta screen, so it worked really well. But it will actually predict 80% of the times it will predict the true values, another 20% of the time it will predict the non-true values. So again, coming back to the code, this was the simplest example of implementing it. I just created a Python interpreter inputs. So what you can do is you can, if you will have worked in web development environments or created APIs, you can expose this entire thing as a REST API by creating a basically a endpoint as slash predict slash, and then in the parameters you actually pass the request parameters, you have actually passing in stuff like age and all, which actually this is how you would actually deploy it in a production environment. Again, I took an example that everyone should be able to understand using the inputs, basic one, but then later on you can do also use the same model. You can deploy it on Amazon AWS or something like Azure. Again, the same example, the same model that we have trained. Only the thing is to make sure that the libraries are compatible, backwards compatible, forward compatible, whatever those things are, and then you can like deploy it anywhere. Okay, so I think we are done. We saw how to predict also. To show that we did all those things and we covered the last 4 parts today. Yeah.